My name is Shanjida. I am currently a second year human biology student at U of T. And so today I'll be going over some commonly asked math questions both at the high school / university and college levels. And if anyone needs any additional schoolwork, help, or needs tutoring, please check the description box below. And other than that, let's get started. Okay, so our first question here says, if cos theta is equal to half, what is cosecant theta and what is cotangent theta? So first of all, if we want to find the value of cosecant, we can basically use the definition of the trigonometric identity of cosine. So basically so let's first address what is cosine of theta. Okay, so basically cosine of theta is equal to adjacent over hypotenuse, right? So if we have a triangle here, right angle triangle, okay, and say this is our hypotenuse, this is our adjacent, this is our opposite side, right? And if we're looking at cosine of theta, let's say this is cosine of theta, okay? So the cosine of theta over here, we can say that this is adjacent over hypotenuse. And so basically from our question, we can say that cos theta equals adjacent over hypotenuse, which is equal to 1/2, okay? And so comparing the given trigonometric function, we can basically determine that the adjacent side of the right angle triangle is equal to 1 and the hypotenuse is equal to 2. So we can say our adjacent side of our triangle is basically 1 and our hypotenuse is equal to 2. So if we substitute the value of the adjacent side and the hypotenuse in the formula of the Pythagorean theorem, so if you remember the Pythagorean theorem, right, it's a squared plus b squared equals to c squared. So we can basically substitute our opposite plus adjacent so we can rewrite this and say opposite squared plus adjacent squared is equal to our hypotenuse squared. And so if we rearrange this equation and to find our opposite side, let's say, we can do it like this. So we just have to move the adjacent to the other side, and so we can say opposite squared is equal to hypotenuse squared minus adjacent squared, right? Because we're moving it to the other side of the equal sign, so the signs have to change. And so we can basically say that our hypotenuse is 2, right? So we can say 2 squared minus 1 squared, which is our adjacent value. And so over here, 2 squared is 4 and 1 squared is just 1, so we get 3. So our opposite squared is equal to 3. And to find basically the value of the opposite side, we don't want square, we just have to square root, right? So if you square root both sides, you basically cancel out the square and you get opposite is equal to root 3. Okay, and so since we have found our opposite side, we can find our another trigonometric angle. Basically we can basically say sine of theta, right? is equal to opposite over hypotenuse. So we can basically say in this case that our hypotenuse is also 2, so we're just using this triangle over here. Okay, so we can say that this is 1, this is 2, and then therefore this is 3, root 3, sorry. And so we can basically plug in the value here, and so we get root 3 over 2. So sine of theta is equal to root 3 over 2. And if you recall that since cosecant, so cosecant is the reciprocal of sine. Okay, so basically we would have to take the reciprocal of sine theta over here. Okay, so if you want to take the reciprocal, we just have to flip the fraction here basically. So what we have to do, so flip sine theta basically. And so what we do here is then cosecant is basically 1 over 3 root 3 over 2, and so this is basically the same thing as 2 over root 3. Okay, so basically so if therefore the value of cosecant, so we can say therefore the value of cosecant theta if cos of theta is equal to 1, 2 is 2 over root 3. Okay, and so now if we want to find, let's say, cotangent of cotangent theta, so if you recall cotangent, so basically cotangent, right, which is cot, is the reciprocal of tan. So now, so for this, to find cotangent, we need to first find tan theta. And to find tan theta, if you remember that tan theta is basically opposite over adjacent, right? And so our opposite was root 3 and our adjacent was 1, and so tan theta is basically root 3. Okay, and now if you want to find cotangent theta, it's basically the reciprocal, so you have 1 over root 3, and so basically cotangent is 1 over root 3. So we can write therefore the value of cotangent theta if cos theta is equal to 1/2 is 1 over root 3. Okay, and so this is our answer, and so they have got 2 over root 3 and 1 over root 3. So yes, this is correct. Okay. Okay, so our next question says, simplify to root 3. Okay, so simplify to root 3. So basically, this is a radical, right? To simplify, basically, so they're saying to simplify, so basically they're saying to simplify root 3, right? Because this is a radical. Since 3 is not a perfect square, so basically we can say the answer, since basically 3 is not a perfect square, right? You can't really break down 3 anymore. There's no, you don't have, so since 3 is not a perfect square, there's no further simplification. So basically, if you want to evaluate, so if want to evaluate or get evaluate the exact answer, right? You can put this into a calculator and just put 2 root 3, and this is approximately equal to 3.4641, okay, in decimals. And so this is what they've got here, okay, and this is correct. Okay. So our next question says, how do you evaluate tan of 30 using ratios in special triangles? Okay. So we're given, so let's write given tan of 30 degrees. Okay. So what we need to find is basically evaluate the given function using special triangles. So required is basically evaluate, right? Evaluate tan 30 from special triangles. So our solution here would be to first draw out the special triangle, and so okay, we have a right angle triangle right here, and so let's say this is basically, this angle is 60, this angle is 30, and so therefore that is 90. And let's give values for the side lengths, and so we can just say this is 2a, this is a root 3 basically. Okay, and so what we can do here is to find, let's first find tan theta, or no, let's just say, let's find tan x, okay, just to find what tan is. So tan is, as you know, it's opposite over adjacent. And so if you want to now find tan of 30, right, as the question implies, so tan of 30, if you look at this angle right here, and if you see what the opposite angle would be, it would be A right here, and adjacent would be A root 3 right here, right? So I'll just use another color, right? It would be A and A3, right? And so when we're gonna write the ratio, it's gonna be A over A root 3. And so basically A in this case is just a coefficient, since it's just, there's no, A is in this case is just 1, so like that, A equal 1 basically, and so therefore we have tan 30. So let's say tan 30 is equal to basically 1 over root 3. And so when you're rationalizing, so when you just so basically 1 root 3, you can 1 over root 3, you can write this as in another way, like multiply root 3 times root 3. So this is multiplying basically. You can also write it this way. It's basically the same thing. Root 3 over 3, right? If you have two radicals that are the same, it's basically what's inside the square root. And so the radicals basically cancel out and you basically get 3. And so therefore you can say that tan 30 degrees is basically equal to root 3 over 3. So root 3 over 3 and 1 over root 3 is basically the same thing, but if you don't want the radical in the denominator and want it in the numerator, you would have to just multiply the numerator and the denominator by root 3. And so this is what they have got. This is right. Okay, so our next question here says, what is 6% as a fraction in simplest form? So basically a percentage is defined as a part of a whole which is expressed as a fraction of 100. So basically a percent, right, is the number, so if I want to put it in simple term, is the number out of 100 basically. So 6%, so 6%, you can write this as 6 out of 100. Okay. And so if then you can simplify this fraction. So this is basically the fraction, right? And so if you want to simplify this fraction, you would have to find a number which is both divisible by 6 and 100. Since 6 and 100 are even numbers, you can try with 2 basically. So you can say simplify 6 over 100 by dividing numerator and denominator by 2. Okay, so you have 6 over 100, right? You can divide by 2, And so divide by 2 as in, I'll just write divide by 2, so divide by 2, divide this by 2 also, and so you get 3/50. And so if you want to divide this even more, you can see if, so the only thing that is left is 3, and you can't really divide 3 by anything. So your next option would be to see if 3 is, if 50 is divisible by 3, and which is not. And so you can say that the percentage, so therefore the percentage when written as a fraction is equivalent to basically 3/50. Okay. And so this is the answer. This is our next question says, evaluate secant of pi/4. And so, so we can I'll just write out the question. Evaluate secant of pi/4. Okay. If you recall, if you want to convert this, so they're telling us to convert this into a fraction, basically a ratio. And so in order to do that first, we can first say that what is basically secant. So secant is basically the reciprocal of cosine, right? So secant is the reciprocal of cos, right? Cosine. And so we can basically say that secant pi/4 is equal to 1/cos of pi/4. Okay. And so what we can say here, so basically pi/4, if you want to convert this into an angle, for example, so I guess it would be easier if you convert this into an angle. So if you remember that pi is basically 180, right? If you're converting it from radians to angles, so pi is basically 180, and you divide this by 4, and you get 45 degrees, okay? And so if you recall that 45 is one of our special angles, right? And so if you remember the triangle, basically cos, so we'll just deal with cos here. Cos of 45 degrees is basically 1/√2, or same thing as √2/2 basically, but we'll just say 1/√2. And so what we have here is basically to find, so we need to first find, so we have to go back and find what secant of pi over 4, which is the same thing as 45 degrees, is equal to. So since we know that cos of 45 degrees or pi over 4 is 1 over root 2, we can basically now find secant of pi over 4. So secant, so I'll just rewrite this 45, or okay, angle 45 is the same thing as pi over 4, right? It would be 1 over 1 over root 2. So this is basically the same thing. And over pi over 4 is basically just root 2, right? So if I want to just show this, it's just 1 times root 2 over 1, and so you basically have root 2, and so therefore secant of pi over 4 is equal to root 2. Okay. And yes, so this is what they have got. Okay, so now we have how to convert 30 degrees into radians. Okay, so when you're converting degrees to radians or radians to degrees, there is a conversion factor. So I'll just write the conversion factor. Conversion factor, which is basically 360 degrees is equal to 2 pi radians. So if you imagine that this is this one circle, and so the circumference, if you go around this whole circle, it will be a full 360 degrees, which is also equal to 2 pi radians. So basically the distance around, right? So this is all equal to, actually, so yeah, the degree, so if you go around this whole circle here, this is all equal to 360 degrees, which is also equal to 2 pi radians. And so if you want to convert, in this case, 30 degrees to radians, you just have to so you just have to do this 30, right, your degrees on one side, times 2 pi radians over 360 degrees, right? And so basically what you have here is you can basically divide 360 by 30, because 30 is divisible, 360 is divisible by 30, and so you have here, if I convert this, you get 12 degrees. And so what I have, since 2 is divisible by 12, you can just also, so you basically have 2 pi radians over 12, right? And so you can basically, sorry, 12. You can basically simplify this even more, and you basically have 6, right? And so you have pi over 6 radians. Okay, so you can basically say that therefore 30 degrees is equivalent to pi over 6 radians. Okay. So our next question says, what is square root of 324? Okay, so let's first express 324 as a product of its prime factors or prime numbers. So 300 is equal to what, right? And so we can basically say what is the lowest factor of 324. So 324, so if we have branch here, so 324, right? So if we basically 324 divide this by 2, right, you have 162 and 2. You can further divide this by 2, right, and you get 81 times 2. You can further divide 81, and which is 9 times 9, right? And you can further simplify 9, and you basically get 3, 3, 3, and 3. So as you can see that these 2's and these 4 3's are our lowest prime factors of 324, and so we can basically express this as root 324 is basically the same thing as if we say 2 times 2 times 3, 3 times 3 times 3, right? And so if we were to group this together, we have basically 2 times 2, and we have 3 times 3, 3 times 3. Okay, and so you can further write this as 2 squared, right, times 3 squared times 3 squared. And what you basically have here, since it's under a square root, your squares are going to get cancelled out, and you get 2 times 3 times 3. And so 2 times 3 times 3, 2 times 3 is 6, times 3 is 18, and so 320, square root of 324 is equal to 18. Okay? And yes, this is what they have got. Okay, next question says, what is square root of 128? So same thing, let's first express, so let's say express square root of 128 as a product. So you know what a product is, right? It's an answer derived from multiplication, basically, of numbers. So we can say that 128, so since it's an even number, we can suppose that it's divisible by 2. So 128 divided by 2 is 64, right? And so we can further divide this by 2, and you get 32 times 2. Further divide this by 2 as well, and you get 16. And further divide 16, and you get 8 times 2. And further divide 8, you get 4 times 2. Further divide 4, you get 2 as well. And so as you can see that our lowest prime factors our fact. So you can see that we have a chain of 2's here. And so how many 2's do we have? 1, 2, 3, 4, 5, 6, 7. Okay, so we basically have 7 2's here. And let's first express this under a square root, basically. So we can also write this as 2 times 2 times 2 times 2 times 2, right? So we have 7 2's here. So if we want to group this to 2, so 2 times 2 times 2, you have 1 2 left, right? And so we can further say that this is 2 squared times 2 squared times 2 squared times 2, right? And so 2 squared, so the 2's that have a square, their square will get cancelled out because of the square root. So basically have 2 times 2 times 2 times square root of 2, right? Because that's the last 2 does not have a squared. And so we can basically multiply these 3 2's together and you get 8. And so 8, and then you have the remaining square root 2 and it's multiplied by that. And so you have 8 root 2. And so basically square root of 128 is 8 root 2. Okay, and this is what they have got. So this is correct. Okay, so our next question says, what is 3 pi over 4 radians in degrees? Okay, so now we have to convert this radians into degrees. So the conversion factor for this which is basically 360 degrees is equal to 2 pi radians. 2 pi radians. Okay, so now we have to convert 3 pi over 4 radians into degrees. So what we do here is basically 3 pi over 4 radians times 360 degrees over 2 pi radians. Okay, and so what you get here is you just have to multiply the top and the bottom, and so you get, so basically 360 times 3, we basically get, so we can basically cut out the radians here, and what you get here is 1080 degrees over 4, and if we divide this by 4, if we divide this by 8, right? Because 4 times 2 is 8. So you have 1080, divide this by 8. You get 135 degrees. And so therefore, our closing statement, therefore 3 pi radians, 3 pi over 4 radians is equivalent to 135 degrees. Okay, and so this is correct. So the next question is how to multiply fractions by whole numbers. And so basically in general, when you're multiplying fractions, so let's say you basically multiply all the numerators going across and then all the denominators going across, okay? So this goes to like basically to proper and improper fraction. So an example we can see here that says, let's say for example we have 1/3 times 3/2, and so you basically multiply the top and you multiply the top and multiply the bottom, and you get 3/6, which is, you can also simplify this even more, right? Divide both by 3, and you basically get 1/2. So however, when a fraction is multiplied by a whole number, you turn the whole number into an improper fraction by making the whole number the numerator, and then you have 1 in the denominator. And what I mean by that, and then you can proceed in multiplying how we did in the first example. So basically, so let's say we have 3 as our whole number, and you multiply this by 3/2, which is a fraction, right? We can first rewrite this 3 into an improper fraction. That would be 3/1, right? So 3/1 is basically 3, and you just multiply 3/2, and what you get here, so you multiply the top with the top, so the numerator with the numerator, and the denominator with the denominator, and what you get here is 9/2. Okay, and so basically the answer is when a fraction is multiplied with a whole number. So when is multiplied by whole number, you basically turn whole number into improper fraction. And we just saw an example, so basically example 3, and you turn this into 3/1. Okay, and then what you do is basically after you multiply numerator with the numerator, and denominator with the denominator. Right, and for example we just saw 2. You have 3/1 times 3/2, so you multiply these two, and you get 9/2. Okay, so you just multiply across from each other, so so you just multiply across, and so after this, multiply the numerator going across and all the denominators going across. Okay, so now our next question says, what is square root of 8? Okay, so to find the root of a number, we have to first express this as a product. So let's say express as product. Okay, so what I mean by this, so let's express 8 as a product, and you know 8 is divisible by 2, and you have 4 times 2, and you can further divide 4 by 2, and you have 2 times 2, and so our prime factors, least common multiples, basically are 3 2's in this case. So let's rewrite this. Square root of 8, rewrite this under the square root, 2 times 2 times 2, basically. And we can first, so for the first two 2's, we can basically square them, because it's the same thing as saying 2 times 2, and we have times 2, right, left. And so the 2 squared, the squared would be cancelled out because of the square root, and so we have 2, but since the other 2 is not squared, it would basically leave the square root on it, and so we have square root 2. And so basically square root of 8 is basically 2 square root 2. And yes, this is correct. So our next question says, what is the formula of the area of a half circle? Okay, so the area of a circle, so let me draw a circle. Okay, so we have a circle, a perfect circle, but a circle here, and they're saying to find the area, right? And so the area would be everything that's inside this circle, right? And so let's say go to area. Oops, let's say this, no, okay, fine. Let's say that, so basically this is our area, right? And so the area of a circle, a full circle, is pi r squared, okay? Where r is basically, so r is basically the distance from the middle across, okay? So this is our r basically. And so so basically this is our r, right? And so r is called the radius, whereas if you want to find the full distance of the circle, it's basically called diameter, right? And so diameter would be, so diameter is equal to 2 times the radius. But however, we're trying to find the area of a half circle, and so the half circle would be basically something like this, semicircle. Oops. Okay, so we have, okay, so we're trying to find the area, so this area right here. And so as you can see, the area of a full circle is pi r squared, so you probably could imagine that the area of a half circle, which is also called a semicircle slash semi, is basically, since it's half, so you can probably imagine that the area is also going to be half, and so you can say that area of a circle is equal to pi r squared, and so area of, I'm just going to say semicircle, is basically pi, basically over 2. Okay, and so we can say pi r squared over 2. Area of semicircle is equal to pi r squared over 2. And yes, this is what they have got. Next question says, how do you graph x equals -2? Okay, so we're given the equation, so let's say given x is equal to -2, right? This is basically the same thing. So x is equal to -2, so this is basically saying that x is equal to c. Remember, if you have our standard equation where a x squared plus bx plus c is equal to 0, or is equal to y basically, right? So in this case, x in this case we can say y is equal to c, but they have just changed, or actually we can just say this case just plus c is equal to x. So from here we can just say x is equal to c. Okay, and so basically this, to graph this, it has a property of a vertical line parallel to the y-axis. So let's say to graph, right, it says a vertical line parallel to the y-axis and so it passes through all points in the plane with an x coordinate of c. Okay, so it passes the point x equals -2, and so basically to draw this, okay, we can, so I'll just have, okay, I'll have, okay, let's say, so x equals to -2, right? So our negative values of x is always on the left side of the graph. So let's say this is 0, this is -2, okay? And so this is y, this is, oops, this is basically like -x, okay? And so when we're drawing this, to draw this line basically, or graph it, since it says it's a vertical line, so it's gonna go up and down basically, and not across, it's gonna pass through the point x equals to -2, and so we can basically say that passes through this point, okay, -2 basically. And so this is, this I'll just, this is, sorry, this is x, right? And so we've basically fulfilled all the properties of this graph. It's vertical and it passes through the point x equals to -2. so this is how the graph is supposed to look like, basically. So I'll just not draw the arrows here. Okay, and so this is how it's supposed to look like. It's basically a vertical line that passes through x equals to -2. And yes, this is correct. Okay, our next question says, what is the area of circle with diameter is equal to 3.4? Okay, so the area of a circle is, as we've mentioned before, is pi r squared. And so basically r d is equal to 2 pi r, basically, right? Sorry, 2 pi r, or we can also write r is equal to basically r is equal to 2r, sorry, 2 times r. R is equal to d over 2. Okay, and we're given d, so given d is equal to 3.4 meters. And so if we just plug this into our equation, let's say a is equal to pi r squared. And so for r, we're going to substitute d is equal to r is equal to d over 2. So we have pi is equal to pi times d over 2 squared, right? And so what we have here is basically a is equal to pi d squared over 4, right? I just squared the top and the bottom. And so what we have here, so if we just evaluate this, you get pi is 3.14, d is 3.4 squared. And you divide this by 4. What we get here is approximately, so a is approximately equal to 9.079 meters squared. So keep in mind the units here when we're dealing with area. It's always the unit squared. And so in this case it's meters, and so it's meters squared. And so this is what I've got, and this is correct. And so that was basically the end of our session. If you really like this Q&A, please subscribe to this channel. It's OneClass. And other than that, if anyone has any personal questions they want to ask, follow the description box below and follow the links and ask your questions. Other than that, this is Shanjida, and I'll hope to see you soon.